Are we ready?
Yep.
Hello, welcome everybody. Welcome to the practice session. This is Jyotsna. I'm the Colorado Chapter State Director for Math Kangaroo. I've been involved for Math Kangaroo for the past almost 11 years. My kids grew up with Math Kangaroo. I have two daughters who are in college. One graduated a couple of years back. The younger one is still in college. Both of them grew up with Math Kangaroo. Math is their passion and they love doing math. Even in college, they're practicing today. Even today, they're practicing math. I have two guests today here, Kevin and Michelle, who are going to be your guests. I think they are going to run the show for the rest of the night. Let me introduce both of them today. I'm going to start with Michelle. Michelle is a 10th grader. She loves math and she's participated in many competitions. And last year, she received an honorable mention in the University of Maryland math competitions. Outside of math, she enjoys playing violin, volleyball, and petting her cat. Welcome, Michelle. Kevin. Kevin is a current junior from Texas, and he is placed in the top 24 on the USA JMO and is a second-time AMC 10 Distinguished Honor Roll winner. He also runs a national nonprofit organization called FMath, which aims to raise money for communities in need through math competition classes. Welcome, Kevin. After both of you, Michelle and Kevin, the screen is yours.
Hi, everyone. My name is Michelle. How's everyone doing? So our icebreaker for today is, when you guys eat pizza, do you like fold it or do you just eat it normally? Or maybe you guys like are weird and use like a fork and knife. Like, how do you eat your pizza? Okay.
Normal. I don't fold it. Yeah, I eat it normal as well. I know some people who fold it. You eat it backwards. Wow. Like
What?
crust
Like,
first?
huh? That's awfully weird. I have a few friends who like eating the crust of the pizza more than the actual pizza part, and I just think it's so weird. Because it's
Yeah.
like, at that point, you're eating bread, you know?
Fork and knife. That's also something I haven't really heard of a lot. You eat it upside down so the flavor lands on your tongue. Oh, that makes sense. I thought like
Oh,
yeah, that's interesting.
but I feel
Sideways.
like if you ate a pizza upside down, wouldn't like the cheese, especially if it was like warm, melt and like get all over yourself? Or does that not happen?
Use
Okay.
hands. Yeah, I'd be a little concerned if you weren't using hands, to be fair.
I think I saw a few people who said with a fork and knife, which is really weird.
Chopsticks. That should be a secret.
Chopsticks.
Yeah. I can see like someone going on America's Got Talent eating pizza with chopsticks because that definitely seems very hard to do.
Uh-huh. Yeah, I feel like a pizza slice is just too big just to use chopsticks to hold. Like I feel like it would just fall.
Yeah, definitely.
I used to have a friend where every time I go to her house, her mom would bring like a pizza cut into like the tiniest of squares and we would just eat it like chips.
Oh, wow. That's interesting. Yeah,
Uh-huh.
that sounds like something really fun. Unpopular opinion. I despise NYC pizza, prefer Chicago pizza. I actually went to New York City like a month ago. The pizza is really good though. I don't know why you despise it.
I feel like, yeah, I think I prefer New York pizza just slightly more too. You just, so Alexander says that they just take off the cheese and eat pizza. I'm like rip off the top of the part of the pizza and just eat like the bread part. That feels,
Certainly, certainly something. We have a lot of diversity
Mhm.
here.
Yes, lots and lots of different ways to eat pizza, as it seems. What?
Cheese in the bread separately. Wow.
That is certainly very, very interesting. Like, huh. That is really weird.
Yeah. I just eat normally. Yeah, me too. Anton.
Uh-huh.
From inside out. I don't want to know what that means.
Like, have you seen the meme where there's like a pizza and there's like a kid who's just eating like a bite from every pizza, slice of
Oh,
pizza? Maybe like that?
yeah.
Okay.
Maybe.
What toppings do you guys like on your pizza?
Yeah, that's a good question. I guess this isn't a topping, but I really like buffalo chicken pizza. Um,
Oh, I have never had that ever in my life.
really? It's so
No.
good. You should try it.
Okay.
It's
I will
like
make
buffalo
sure.
wings on a pizza.
Yes, I will make sure I try it. Yeah, I agree with Luke. I just like a simple pepperoni pizza, but absolutely. Okay, I'm getting a lot of pineapple in chat, and I despise pineapple on pizza. Like it is the worst thing ever. Well, I just don't like cooked pineapple. And okay, I'm sorry, Rocky, but pineapple on pizza, not my favorite. Kevin, do you have thoughts on pineapple on pizza?
Okay, wait, this is gonna be such a hot take, but like, I don't like pineapples normally, but on pizza it's fine. It's
What?
like it's like the opposite of everyone.
Yeah, we're complete opposites. Like I love pineapple, just not on pizza, not on anything savory, not when it's warm, you know? Like I don't
Wait,
want to eat a warm piece of fruit.
wait, pineapple like tastes like so weird normally though, but like on pizza it's so good. I don't know.
So weird.
Yeah, wait, surely someone in chat like
Yeah, I
agrees
could.
with me. Yeah, see, I'm hearing a lot of pineapple great on pizza. That's what I like to see.
No, yes, Jacob, no pineapple on pizza.
Aw, dang it. We can't be friends.
Oh, that's so unfortunate.
Yeah.
Oh, Steven says broccoli. That's awfully healthy for like pizza. I remember this one time I took my brother out to get pizza and we ended up ordering something from, shoot, I think it was, I forgot the place. But anyways, it was like really expensive. So I was really confused because it was a small pizza. And then it came out with like this thick of a layer of bacon. And I literally had one slice and died.
Oh, really?
Uh-huh. Ethan
Uh,
says that he once went to a pizza party and one kid ate the corners of the pizza slices. That's not good. Oh, Alex says pizza sucks.
aw.
I disagree with you
Pizza
then.
doesn't suck. Wait, someone like sushi on pizza. I haven't seen that one before. With buffalo wings and hot sauce?
Sushi on pizza.
Yeah,
That is
it's
definitely
really,
very interesting.
yeah. I wonder like how would it work? Is it like a topping? You just like put like small sushi rolls on it?
But would it go really, I don't feel like I want cheese on sushi. Maybe there's been a trend recently going on. It's kind of like old, but like when people make a sushi pizza, like where instead of bread, it's like a layer of rice and then they have like normal sushi toppings. So maybe it's like that. But I
Oh,
don't personally think I would want to eat raw fish with cheese on top. Like that doesn't sound very good.
yeah, maybe they mean like that. Yeah, like having like, yeah, I didn't think about that. That's actually really interesting. Like having like the pizza be sushi.
Uh-huh.
Candy on pizza is amazing. Oh, that's
Candy.
really something I haven't tried before. I can't lie.
You know, I really want to try like a Nutella pizza. Like not
Like,
Nutella on a pizza, but like a piece of bread and then like shaped like a pizza with Nutella as like the sauce and then like strawberries as toppings. Yeah, like candy pizza.
that'd be so cool. Yeah, like, oh,
Uh-huh.
wait, hold on. If you ever see that as a business in the future, you know who started it.
I do think it's actually a thing. Um, but
Yeah.
unfortunately, I have never gotten the chance to try it. And I see people are asking when we are starting. So let's just go ahead and jump into the first question.
All right. Okay. So the first question is, drum roll, please. I think it should be this one. So in this picture, in how many places in the picture are two children holding each other with their left hands? So I guess like this one, so to begin with, right, we want to look at how many places in the picture two children are going to hold each other with their left hands. The main trick to this is like we want to like realize that some people are like facing one way and some people are facing the other way, so it's kind of tricky that way. But like let's look at the first two, right? So the first two, they're both faced like one way. So one is holding with their right hand, as you can see, and one is with their left hand. So this wouldn't work. This is no bueno. But the second one, both of them are actually using their right hands, as we can see. So also no bueno. The third one, though, they're both, one of them's using the left hand. The blue shirt guy is using his left hand, and the other guy is using his right hand. So also no bueno. So it looks like we're not having a lot of luck today, but it's so that's, the next one is also, one left and one right, so we can't have that one. But the green skirt girl and the blue shirt boy, they're both using their left hands, so we finally have a winner. So we have one pair that are both using their left hands. And finally, the last pair, both of them are using their right hands, unfortunately. So it looks like we only have one pair total, and our answer will be A, or 1.
Yeah, exactly. One small trick we could notice to save ourselves a little bit of time is if we have two people facing in the same direction and holding hands, we know that whatever hand they're holding, like, can't be the same. For example, if I'm holding someone if someone's facing me in the same direction, so like this pair here, we know whatever hand this girl is using, the other girl is using their other hand, because if you hold, it's like a left, right kind of situation. So that is something you guys can notice and maybe save just a tad bit of time. And on to our next question, which is puzzle pieces. Okay. So we have when 5 pieces shown fit together correctly, the result is a rectangle with a calculator written on it. What is the answer to this calculation? So we have puzzle pieces. Each puzzle piece contains a number or an operation, and we're just trying to figure out what this puzzle piece ends up piecing together. And the first thing to notice, or at least the first thing that I noticed, is that this is a flat end, like the 0 is a flat end, and then the 1 also has a flat end. So we know that that must be the ends of our puzzle piece. And now going from left to right, we notice that for our one piece, which is here, this has like an empty like C shape. So whatever fits next to that one must have like a filled shape. And out of the rest of our numbers, we have a plus sign with this filled shape, a 2 with this filled shape, but this other 2 does not have a filled shape. So we kind of have 2 possibilities here, where we could have a 1, 2, or we could have a 1 plus. And now just like doing a little bit of casework, we can say, okay, what if it's this 1 and then a 2? And then taking a look at that 2, the end of that 2 has a hole, and so we know that it has to be fit with this plus sign. So in this case, it would look like this. And with the plus sign, the other side is a hole, and so it must fit this 2, this other 2 here. And finally, because this 2 ends up having like a little sphere-shaped thing, it fits into the 0, and so we get that this is our operation. We can try the bottom one to see that it doesn't work, but the reason it doesn't work is because this plus sign has 2 like filled up thingies, and so the next shape has to be this 2. But because we've used up all our numbers, it means the next one also has to be a 2. But because this 2 has like a sticked out thing and this 2 also has a sticked out thing, they don't fit. And so we get that 12 plus 20 is equal to 32, which is our answer. Kevin, do you have anything to add?
No, I think you explained it actually really well. And it's really cool how this is like this puzzle piece kind of question. There's actually like a lot of math, in it, and it's really cool that, you know, we have to like rearrange these different like puzzle pieces to really figure out like, you know, what exactly the equation is going to be. So I thought you actually did a really good job explaining it. Without further ado, I think we can move on to the next question. Sorry. So the next question is going to be about Karen, and he's going to be painting the walls of her room green. So the green paint is often, or is too dark, so she mixes it with white paint. And she tries different mixtures, so which of the following would give the darkest green color? So, you know, I guess like we first want to understand, you know, what does the darkest green color mean, right? So, you know, I guess since, you know, she's mixing green and white paint, you know, probably if there's a lot of white in the paint, well, it's probably not gonna be a very dark color because white is obviously, you know, not a very dark color. So we want to probably include like more green and less white. That's gonna make the darker color. So the main idea to this problem is, you know, we want to figure out for each of these answer choices, how much of it is going to be green and how much of it is going to be white. Well, for this first one, you can see that, you know, there's 1 part green and there's 3 parts white. That means that, you know, there's going to be 1 part green, and we have to be careful here because it's actually not, you know, 3 parts total. We actually want, you know, the percentage of the entire thing that's going to be green, and that's the entire percentage is going to be 4 parts. So it's not 1/3 that's going to be, you know, the percentage that's green. It's actually going to be 1/4. So it's important to be careful here. So, you know, 1/4 of the paint is going to be green paint. Similar for option 2, you know, we can see that 2 parts are going to be green out of 2 plus 6, or 8 parts total. So this is also going to equal 1/4. Now we can kind of see a pattern going on here, right? 3 divided by 3 plus 9 parts total is also going to be 1/4. And finally, 4 over 4 plus 12 parts total is also going to be 1/4. So we can see here that all these are all going to be, you know, 25% or 1/4 green. So we can conclude that they're both going to be equally dark. And that's how you want to do this problem. Again, you just want to convert into like a common fraction for each of them and just compare the fractions.
Yeah, exactly. So Kevin just explained that question wonderfully. So because the ratio of green to white paint is the same for all of them, they're going to actually end up being the same color. And now on to our next question, which is about the number. Okay, it's a really big number. So I'm not even going to try to say it. 502.1972970. And it's written on a sheet of paper. And Julian cuts the sheet twice, so he gets 3 separate different numbers. And we're asked to find the smallest sum that he can get by adding these numbers. Now, the key part to this question is realizing that if I have an n-digit number and an n-1 digit number, whatever that n-digit number is going to be greater than this n-1 digit number. So in other words, if I have a number with a lot of digits versus a number with less digits, no matter what those digits are, the number with the largest amount of digits is going to be greater. So for example, if I had a number like 100, it's always going to be greater than any number with 2 digits. And so in order to try to minimize the sum of the numbers, we should try to minimize each of the individual numbers. And we can do this by trying to make sure that they each have as little digits as possible. So in this number, we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 digits. And so we want to split it into a number with 3 digits, a number with 3 digits, and a number with 4 digits. So maybe we could split it like this, or we could split it like another way. And now we just have to figure out where we split it. So one option is to have it split like 3, 3, 3, 4, which would be this case, 502.197 and 2970. Another case would be if we were to split it in 3, 4, 3. And that would be 502.1972 and 2970. and 970. And the third case is if we were to split it in 433. Very sorry, this is very messy right now. 5021, 972, and 970. So in all three of these cases, we have two 3-digit numbers and one 4-digit number. And when we're adding these numbers, the thing that is going to contribute most to the sum is going to be that 4-digit number, because that 4-digit number is going to hold the most weight. In particular, the thousands place is going to hold a lot of weight. So in this number, this 1000 is going to add the most or contribute a lot to this number. And so if we take a look at each of the possible 4-digit numbers, in this one we have 1972, this one we have 2970, and this one we have 5021. I know because this number is going to be mostly based on this thousands place, and so I want to minimize this thousands place as much as possible. And yeah, so exactly like Britvik said, because 5021 is so big, this is definitely not going to be our sum. And similarly, we can kind of conclude that because this is a 2 and this is a 1, this is reasonably just not going to be our sum. And so adding up these three numbers, 343, 502, 1972, we get 7, to carry the 1, 8. Wait, did I do math wrong? Hold on. Wait, Kevin, do you see my arithmetic mistake anywhere? Oh yeah, so this is a carry 2 over. Wait, no, it's not.
Sorry, like the chat's kind of part of it.
Oh, okay, my bad. So 342. Oh, okay, I completely wrote the wrong numbers. My bad. 502, 1972, and 970. And summing that up, we have 4, 4, 4, 3. And so our answer is 3,444. Thank you, Jade, for catching my mistake. Yeah.
That's a great solution, and I think like also it's like really important. Like I guess like it's also like a really good idea. You know, like it's also really great that you can like catch your mistakes, because like that's often like something that's like really hard to do. So like, just going back and just making sure like everything is like which part's wrong, which part's right is really important, especially like on like actual contests. Not making silly mistakes is like really important, and so it's always great that you can like catch these mistakes. Okay, so moving on. We can talk about this problem now. So the diagram shows 3 hexagons with numbers at their vertices, but some numbers are invisible. And the sum of the 6 numbers around each hexagon are 30. So what is the number on the vertex marked with the question mark? Okay, so we know that the sum of the 6 numbers around each hexagon is 30, right? So we know this is 6, this is 3, this is 3, this is 6, this is 1, and this is 2. So essentially what we know is that the sum of all 4 numbers here is going to be 12, I believe. So since we know the entire hexagon has sum 30, that tells us that these two circles combined are going to have sum 18. Now similarly, we know here that these two have sum. Oh, I don't know why I did that. So these two have sum 10. These two have sum 13. And the total sum is going to be 30, so that means that the sum of these two circles is going to be 30 minus 10 minus 13, or the sum of these two circles is going to be 7. So we know the sum of these two circles are going to be 7, and the sum of these two circles are going to be 18. So the sum of all 4 of these circles is going to be 18 plus 7, which is going to be 25, plus 1 here, which is going to be 26. So the sum of all 5 circles here, so basically all 6 circles except the circle that we don't know, the sum is going to be equal to 30. Or yes, the sum of the 5 circles that we do know, the sum is going to be 26. And adding the sum that we don't know, the total sum is going to be 30, which means that the sum that we don't know, the number with the question mark, is going to be 30 minus 26, which equals 4, which is our final answer.
Exactly. And yeah, So I think Kevin explained that perfectly. And on to our next question, which is Ranja has 4 clear tokens and Wanja has 4 white tokens. They play a game in which they take turns placing each of their tokens into 2 piles. And Ranja, the one with the clear tokens, places her token first, and we're asked which one of these piles could they not create? I think there are many ways to approach this problem. Let's just try simulating each of the piles and seeing if there ends up being a way to an issue we end up encountering. So with pile A, we know that since Ranja places her token first and then Wanja places her token next, what we're going to have is 2 cases. Either Ranja places her token here, and then Wanja places her token here, so it looks like this. Or another case, which is Ranja places her token here, and then Wanja places her token here. So in the case of A, it is clear that we're in this scenario on the left. And so after Wanja places her token, Ranja is now Ranja's turn, and she's going to place a clear token. And so she's following just what A looks like. She's going to place it here. And after that, it is now Wanja's turn. So she's going to place a gray token. And so she's going to place it here, or a white token, my bad. And then Ranja is going to place hers here. And then it is now Wanja's turn, and she's going to place it here. Oh, yeah, it's Wanja's turn. She's going to place it here. And afterward, it's Ranja's turn. So she has a clear token. But there's nowhere for her to place it. So it seems like we have an issue with A because Wanja can't go twice in a row. So we have this simulation here where our tower kind of looks like this, but now it's Ranja's turn to place a clear token, and following A, there's no more spots for that token to go in this pile. And well, obviously it can't be here. And so the answer is A.
Yeah, absolutely. And I guess like one important thing to note about that problem
Wait,
is
my bad. I think it's actually E. Hold on.
oh.
I'm getting some chat saying it's E. So backtracking a little bit, take a look at E. So yeah. So what did I do wrong with here? So Ranja goes here, then Wanja goes here, and then Ranja goes here, and then Wanja goes here, and then Ranja goes here, and then Wanja goes here. And then where would Ranja go? Oh, okay, never mind. Yeah, I see the issue because when you go here, when Wanja goes here, she can actually go here instead, which makes it possible for Ranja to go here at the end. So let's take a look at why it is according to chat E. So in this case, Ranja first places her clear token here, and then Wanja places her token here, and then Ranja places her token here. And now Wanja has 2 choices of piles. She can either go in the first pile or the second pile, but because we know that Wanja has to go next, we have to place Wanja's tile such that Ranja has a place to go. And so Wanja needs to go here so that Ranja can place her pile here. And now we're kind of left with a situation where after Wanja places her tile, the next tile, Ranja has nowhere else to go because she needs to place her tile here since this tile is already filled up. But because in E, this tile is already completely filled, it actually is not possible. So the answer is E. Yeah, my bad for that mistake.
Yeah, no problem. And I think this problem's like also really cool because you can kind of see like, like this playing the game idea and like really trying to like, use some like intuition to try to see like, which pair of tiles you can and can't create. And yeah, the answer is E. So the next question says there's a single train track between points X and Y. So a train company wants one train to leave from X and one train to one train to leave from Y daily. And moving with constant speed, it takes 180 minutes for a train to make a trip from X to Y and 60 minutes from Y to X. So they want to build a double track to avoid a crash. And we want to know where the double track would be. Okay, so basically here, you want to like the double track to probably be at the intersection point, right? So we want to know where this intersection point is going to be, and then we're going to build the double track there. Because otherwise, it's kind of pointless to have I think it's kind of pointless to have a double track. So we can see here that moving so we know that both trains has so one train to leave from X and one train to leave from Y at the same time, right? So it takes 180 minutes for a train to make a trip from X to Y and 60 minutes from Y to X. So essentially, I guess if you want to think about speeds, well, the speed from X to Y, that speed is going to be a third of the speed from Y to X. We can see this because they're going, the same distance, but one is going 3 times faster than the other. Or sorry, it's taking 3 times longer than the other, so that means that speed is going to be 1/3 of the other because d equals rate times time. Remember that, if time is going to increase by 3, that means rate is going to decrease by a factor of 1/3. So, that means that the one that, is going 60 minutes from Y to X is going to be 3 times as fast as the one that's going 180 minutes. So 1, 2, 3, 4, 5, 6. Now, given this information, what this tells us is that, let's say both cars intersect at time t, right? So at time t, well, we can see that, one train is going to have gone, so the train that's going from Y to X is going to have gone 3 times the distance than the train from X to Y. The reason being is it's just 3 times as fast, right? Like I said before, this train is just going to be 3 times as fast as other trains. So if the other train speed is s, this train is going to have speed 3s. So what this means is that, again, 3s means that it's traveling 3 times the distance, and they have to intersect at some point, right? So we want to figure out the point where, the distance between X to the point is going to be 3 times the distance from the point to Y, essentially. Now, given this information, well, we can count, how many points are there total? Well, there's one, or how many segments are there total? Well, there's 1, 2, 3, 4, 5, 6 segments total. And then we can see here that, sorry, I'm gonna adjust my setup a bit. So we can see here that, this one's gonna take 3 times the length of the other segment. So essentially, again, using some ratios, its total distance is going to be 3/4 the total distance of the track, the one that's going from, Y to X, actually, not X to Y. That's why it's important to be really careful. So the Y to X one is going to be 3/4 of the track, and so like this distance from Y to the intersection point is going to be 3 times the distance, 3/4 of the entire distance. And since the entire distance is 6 segments, that means that it's going to be 3/4 of 6 segments, or 4.5 segments. So I'm going to use a different color. 4.5 segments is going to be here to here to here. That's 4 segments, and we want 1/2 of it. So the middle of the intersection, or the double track, is going to be here. So that means the double track is going to be built between the first and second segments, like this. And that gives us answer choice B, I believe. If we check if that's right or not. And drum roll, please. Yes, it is B. So, again, distance equals rate times time. We can use that to set up some ratios to solve the problem.
Exactly. And moving on to our next question, which is that the picture below shows 3 gears with the black gear tooth on each, and we're asked to find the picture that shows the correct position of the black gear after the small red gear has made a full turn clockwise. And because every single like small tooth on the gear looks the same except for the black one, we need to keep track of where the black gears are located after this red gear has turned a full clockwise. And I think the most easiest black gear to start with is just the one on the red gear. After the red gear has made a full turn clockwise, the black gear is just going to end up being right where it is. So looking at our answer choices, it can't be B because that black gear is not where it was originally. And now we have to think about the black gears on the purple and on the blue. So on the red gear, I count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 gears, 10 teeth. And then on the blue/purple gears, I count 1, 2, 3, 4, 5, 6, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13 gears. And I think the blue and purple gears actually have the same teeth. And so one thing I noticed is that for every gear, this red gear is going to turn. So for 10 rotations of that red gear, the blue and purple one are also going to spin like 10 times. So this gear is going to rotate 10 positions here. And because this blue one is connected to this purple one, this blue gear is also going to rotate 10 positions. And we could count out the positions, but maybe we can get away with just doing some eyeballing. So 10 is greater than half of 13. So we know that after the black gear has rotated, it's going to rotate like halfway through the purple gear and then a little bit more. So in this case, for the purple gear, since the red gear is rotating like this, the purple gear is going to rotate like that. And so looking at the placements of our black gear, we know that it should be somewhere within these spikes. We can count exactly where, but we know it should be somewhere around there. And from that, we can eliminate option C. And now taking a look at the blue gear, following the same logic, we know that it's going to be spinning, because the purple gear is spinning that way, the blue gear is going to be spinning this way. And so wherever this black gear is, it's going to be somewhere around this area. And so we can go ahead and eliminate D. And finally, we're left with choices A and B, and A and E. And for choice E, notice how the purple black gear here is exactly where it started. And this isn't right because when the red gear has done 10 like teeth moves, the purple should only have rotated also 10 gear moves. And we know that for a full cycle, the purple needs to rotate like 13 teeth moves. And so it shouldn't be back where it started. And so we can eliminate E and we get our answer A. Hopefully the answer is A.
Yeah, that's a really
exactly.
that looks great to me. Yeah, that's also a really interesting problem, kind of like using some intuition with like rotations and things like that. Now I think we're almost done. So we have this other problem. Sorry, I'm a little sick right now. 3 pirates are asked how many coins and how many diamonds their friend Greybeard had. Each of the 3 answered truthfully to one question but lied answering the other, and the 3 answers are written on the piece of paper pictured. So what is the total number of coins and diamonds that Greybeard has? So, as you know, we want to figure out how many diamonds their friend Greybeard has. And we're told that each of them answered truthfully to one question and lied for the other. So, one of these is like, for each of one of these, one of them is the truth and one of them is a lie. So we want to figure out which one is the truth and which one is the lie, obviously. So we can start with like looking at each of these questions. One of them says they have 8 coins and 6 diamonds, and this first question is actually really interesting to me because what I noticed when I'm looking at this first question is that essentially what it tells us is that it tells us 8 coins and 6 diamonds is completely different from these other 2 answers. And what I mean by that is there's no other answer that has eight coins, and there's no other answer that has 6 diamonds. And so this tells us, either he has 8 coins or he has 6 diamonds, but not the other one. So that means that, if he has 8 coins, then obviously he can't have 7 coins. So these two have to be a lie. But then that means that, since each of these pirates are telling one lie and one truth, that means that, both of these have to be the truth. And obviously this can't happen because, it can't be the truth that he has both 4 diamonds and 7 diamonds. So if the first pirate is being honest that they have 8 coins, well then obviously they can't have, or sorry, if the first pirate is lying that they have, if they're being honest that they have 8 coins, that means that they can't have 7 coins, and so that this one has to be the truth. The diamonds one has to be the truth, which obviously does not make any sense. Which means that, Graybeard or friend number 1 has to be telling the truth about this one, the 6 diamonds one. Because if they have 6 diamonds, well, they can't have 4 diamonds and they can't have 7 diamonds. That means that, the first statement about the coins has to be the truth for both of them. And but both of them do agree. They both have 7 coins. So we know that 7 coins is going to be the truth. And the 6 diamonds is also going to be the truth. So, in total, they have 7 coins and 6 diamonds. So the total answer is going to be 13. And let's check our answer real quick. And the answer is 13. So great job, us.
Yay. And moving on to our next problem, which is that elves and trolls are given a token with a different number from 1 to 10 written on it. They would then ask what number was on their token, and they all answered with a number from 1 to 10. But the sum of the answers they gave was 36. So we know that each troll told a lie and each elf told the truth, and we're asked to find the smallest number of trolls there could have been in the group. And we know that there exist trolls because the sum of numbers from 1 to 10 is equal to 55. And 55 is clearly bigger than 36. And so some of the trolls must have said a number that was smaller than that had. And in order to find the least amount of trolls there could be, we want each troll to lie as big as possible. So whatever lie they told for the difference between their number and their actual number and the number they told needs to be as big as possible. So for example, if we had 1 troll in our group, to make the biggest difference in the sum, he would have needed to get the number 1 or get the number 10 and then say he got the number 1, because that way, by saying he has 1 and actually having 10, he's going to change the sum by 9. So that's how we make the trolls lie as big as possible. And yeah, so in the case of 1 troll, the maximum lying he could have done was actually get 10 and say he got 1, which would lower our sum by 9, which would give us 55 minus 9, which is unfortunately still greater than 36. So let's move on to 2 trolls. So for 2 trolls, the way to make these trolls lie as big as possible is somehow not as clear, but we do know that for these 2 trolls, they should have gotten the 2 biggest numbers, because that way they'll make the biggest difference by lying. So one of them should have gotten 10 and the other should have gotten 9. And they both need to say that they got the smallest number possible, 1, in this case, 1 and 2. Now, maybe troll 1 got 10 and said 1. Maybe troll 2 got 9 and said 2. Maybe like the orders are changed, but it doesn't really matter. As long as we have that they basically got 10, 9, and 1 and 2. And I missaid the problem. This should be a 1, not a 2. My bad. And in this case, they would have changed their difference by 17. And unfortunately, 55 minus 17 is equal to 38, which still is not smaller than 36. So let's move on to 3 trolls. And 3 trolls, in order to maximize their lying potential, they would have needed to get the 3 biggest possible numbers. So in this case, 10, 9, and 8. And to lie the most, they would have needed to said, hey, I got the smallest possible number. So they would have said 1, 1, and 1. And so by getting 10, 9, and 8 and saying 1, 1, and 1, they would have actually changed the sum by 7 plus 8 plus 9, which is equal to 24. And now 55 minus 24 is less than 36, but it's not actually 36. So maybe something went wrong. Maybe it's like 2.5 trills. Well, not exactly, because what we're calculating here is like the maximum lying potential of the trolls. And so with 3 trolls, they could have actually gotten anything between 0 and 24. They could have changed from the sum from anywhere between 0 to 24, but 24 is just the max number they could have changed. And so with 3 trolls, we can actually have them lie and turn the number 55 into the number 36. And so the answer is B. Now, just make sure our answer is correct. Yep, it's B. And as Emin stated, a possible way for this to be true is for the third troll to have gotten 8 and said 4. Yeah. And that is the end of our live stream. So thank you, everyone. If you guys have any questions, feel free to stay on and ask us in chat. But otherwise, bye. Oh,
Bye,
okay.
everyone. Have a great rest of your day.
Someone asked how we got 55, I assume from the previous question. And I calculated 55 to find what the actual sum of numbers from 1 to 10 would be. So in this case, we're looking for the actual sum, which is 1 plus 2 plus 3 plus ... plus 10. And as Hai has said, Gauss is formula. And so this is actually one of my favorite formulas in algebra. Kevin, do you want to explain it, or I can do it?
You can do it.
Okay, cool. And so basically, this is like a really, really, really big number. We could calculate it step by step. We can do 1 plus 2 is 3, 3 plus 3 is 6, 6 plus 4 is 10, etc., etc. But that's a lot of steps. And what if, per se, we wanted to find 1 plus 2 plus 3 all the way to 100? Suddenly, that's not so nice to calculate. And so what Gauss gave us is a general formula to find the sum of numbers from 1 to n. And Stan says to review the 30-sum question, so we'll do that too. And so what Gauss actually came up with is this idea of pairing the numbers. So we have our smaller numbers, 1, 2, 3, 4, 5 on this side, and we have our bigger numbers, 10, 9, 8, 7, 6 on the other side. And what he realized was that, hey, if I add these numbers, if I paired the biggest number with the smallest number, and etc., I get the same sum. In this case, our sum is 11. And so the sum from the numbers 1 to 10 is just 11 times the number of pairs in 1 to 10, which is 10 divided by 2, which is 5, which gives us this 55. And there's also a more general way to show this formula, which is that since this is an arithmetic sequence, which means that the difference between each of these two numbers are the same. In this case, our difference is 1. The average of each of these numbers is going to be the biggest number plus the smallest number divided by 2. So on average, each number is going to be the biggest plus the smallest divided by 2. And so in this case, our average is 1 plus 10, because 1 is our smallest number and 10 is our biggest number, which is 11 over 2. And if we know the average sum of the numbers and we know the amount of numbers, we can find the sum. So in this case, there are 10 numbers, and so 1 plus 10 divided by 2 times 10 is equal to 55. Yeah. I think someone asked about the 30-sum question. Oh, thank you, MNL, too. Thank you for listening. Oh, so the chat website. Kevin, do you know it by any chance?
Sorry, the website for what?
The chat?
Oh, the chat, like chat relay?
Yeah.
Let me see. I'll try. I actually don't know how like chat works on the student end, but
Me neither.
yeah, I'm actually not quite sure. Sorry. Maybe like this? Yeah, I have no idea. Sorry.
Okay. Oh, Jade says that they made a poem about kangaroos. Very interesting. Chat works. Send to chat really. Yeah, I wonder actually how chat works because it's complicated, right? Because are you guys watching from YouTube or on Zoom? Because if it's probably on Zoom then. But like how it works on from our end at least is we have this website called Chat Relay, and basically that you guys see, and basically it is like a website, and we're able to share that website on our screen through an app called OBS or an app called OBS. It just displays it there. Yeah. Hello, Ellie. I think someone mentioned wanting to see this problem again. Hi, Ellie. Is that still true? Yeah, the 30-sum question. Sure, we can go over that. So we were given 3 hexagons with numbers at their vertices, but some visible, and we were asked to find the sum, the number, and the question mark. And so I don't exactly remember what Kevin did, but I think the first thing he did was find the sum of the 4 numbers we have, like this group here and this group here. And just doing some arithmetic that hopefully I will not mess up. 3 plus 6 plus 1 plus 2 is equal to 12. So we know that the sum of these 4 numbers is 12, and the sum of these 4 numbers, 4 plus 6 plus 9 plus 4 is 23. And because each of these hexagons sum to 30, we then know that this group of 4 here plus this group of 2 here need to sum to 30. So this group of 2 must sum to 18. And with a little bit of the same logic, because we know that these 6 have to sum to 30, this group of 4 plus this group of 2 need to sum up to 30, and so this group of 2 needs to sum up to 7. And now finally, looking at a third hexagon, we know that it also sums to 30, so 30 is equal to this question mark number plus 1 plus this group of 2, which we know adds up to 7, plus this group of other group of 2, which adds up to 18. And so doing some arithmetic, we get that the question mark is equal to 4. Tom asked how to apply to teach this class. It is there's a program called Daily Challenge. You can apply there. There should be instructions on the website. Yeah. Oh, Jade, I love your poem about kangaroo. It is amazing. Kangaroo here, kangaroo there. Kangaroos everywhere. So Stan asked if we would like to play chess. Do you play chess, Daniel? I mean, Kevin. I'm so sorry. Kevin, do you play chess?
I know how to, but let's just say I'm not very good.
Yeah. I'm in the exact same boat.
Yeah. Oh, it seems like a lot of people here play chess. Do a chess match. Well, we can think about it.
I am really bad at chess, like beyond knowing the basic moves.
Yeah.
Yeah.
do it. I'm not. Or, I don't know if we're allowed to or not.
Me neither.
Really. Lee chess. I know a couple of people who use Lee chess. When I do play, I usually like play on Game Pigeon or chess.com.
Hmm. Yeah. I usually play on chess.com. I've been really into puzzles recently, but I just like in between classes when I'm bored, and sometimes during classes too, which is not good. You should not do this. But yeah, I've been really into chess, but I am unfortunately not that good.
Okay, seems like a lot of people want to play chess. Okay, wait, I'll make a. I don't know how chess matches like. How do you make it? I guess I'll make one, and whoever joins first can play me. I guess, or maybe
You
like.
want to work together?
Yeah, sure, we can do that.
Okay.
How does sharing your screen work? Also, okay, let's try this. I'll set like a time limit so it doesn't take too long. Okay, there we go. Oh wait, should I pick a random person? Oh, that's not good. Sorry, I'm trying to use Lee Chess. I've never used it before. How does this work? Oh, play with a friend. Play with a friend. Aha. I think I got it. I think I got it. Okay. I'm gonna send the link in chat, and whoever joins first can play one of us, or maybe both of us. Let's see. Let's see. Sorry, give me one sec. Okay. I don't know if you guys can see this or not, but I'm gonna type it in our chat relay chat. Let's go, guys.
Can you share your screen?
Yeah. I got you. I got you.
Okay.
Zoom, or wait, where is it? Oh, OBS. Wow. Okay. This should work. Oh wait, that's not what I want to show. Sorry, one sec.
Wait, are you working on?
Oh, there
yeah.
we go.
Yeah, exactly.
Yeah, there we go. Okay, I guess I'll wait for someone to join and then we can play a game. Oh, whoops. Whoops. Just curious, does everyone see like my screen, or can everyone like see my link? Because it seems like it's taking a bit. Oh, there we go.
Oh, okay.
Okay, let's see. I'm a little nervous.
Oh, hi, Jade.
Hi, Jade. I think it's your move first. Oh, I'm scared.
It's okay. You got this.
I don't know. Okay, I think that's what you're supposed to do. Hopefully. Uh-oh.
Oh,
I'll take it.
but then,
Maybe that wasn't a good idea. Huh. Oh wait, but okay. Oh no. Hey, I think it should be fine though. I didn't see that one.
you could just take that pawn, right?
Yeah,
I
hopefully.
think. Hopefully, there's not some trap.
Okay. Yeah, that's what I was afraid of. Maybe just kick him out.
Sounds like a solid plan. Use your
Yeah.
bishop? Yeah.
Yeah. And after he gets kicked out, maybe I'll like trade the queen or something. Is that a good idea? Maybe like do this. Should I do that? Okay,
No, but after you should get the bishop out, so when she takes, you don't double your pawn.
Oh yeah, that's right. Wait, maybe like here then, right?
I have no idea.
Okay, let's see. Oh yeah, wait, yeah. Oh, wait,
It's your
watch this, watch.
castle.
Yeah, watch this. I was thinking the same thing. Very nice,
Yay.
like.
Yeah, so true.
Okay, yeah. Now we can take the pawn, right? I I think it's
Yeah.
all. I think it's all coming together.
Wait, is it possible to like have you pinned? That way.
Wait, what do you mean?
Never mind then.
Wait, I was thinking like maybe like rook here. Is that a good idea?
Sure.
Okay, let's go with it.
Then you can check with the knight. No, that's a bad idea. There's a pawn. Don't do that. Don't listen to me.
Yeah, it's okay, it's okay. Maybe like pawn here so I can get my bishop out. Maybe.
Yes.
Okay, sounds like a plan. Yeah, time is tough. Only have 2 minutes, or two, I guess they have less time, so I guess we're doing pretty well in the time game right now. Okay, I was thinking like maybe bishop here then, right?
Yes. And
Exactly.
then check.
Uh, we're doing pretty well so far, I feel like.
Mm-hmm.
Let's see. Okay, so if he moves there, then I don't know. I guess like we've got both our bishops pinned, which is a good idea. Maybe like kick the knight, because like the knight has.
Yes, definitely. Or bring the rook
Or
out.
yeah, I was thinking maybe the rook as well, like maybe here then.
Mm-hmm.
Yeah.
Yeah.
Oh, but then
Connect.
maybe pawn. I think I need to move the pawn first, right? Because like then the knight will jump in.
Yeah.
Yeah, sounds like a plan.
Well, yeah.
Okay, now I can move the rook. Hopefully, looks good to me.
I think so.
Yeah. Let's see. Man, these pawns are really annoying because I want to move my knights, but it's just not. The pawns won't let me.
We can move the bishop to attack. No,
Um,
that's a bad idea.
this one or I was thinking maybe here because like here's
Yeah, me
more.
too. Because then we can like attack the king later.
Yeah, that's a good idea. That's a good idea.
We could attack one of the bishops because it's pinned right now.
Oh
So
yeah,
let's
wait.
see.
So we feel like if
Yeah,
I'm like
that and
like
then
that,
yeah,
yeah.
exactly.
If he takes, then I'll take his. That's smart. I didn't think about that.
But
That's so
like
smart. Yeah.
then
It's,
we move our rook to like a really nasty corner.
yeah. Oh well. Well, you only have 20 seconds left, so you can't listen to us for much longer.
Uh-huh.
Okay. So wait, is my bishop trapped? Uh-oh.
Oh, that's not good.
Good. Think. I think maybe we just do this anyways, and then we'll still
Yeah.
like break the piece, maybe.
And
And
then
then
we take their
yeah,
bishop.
it's good.
And we should be theoretically up a rook.
Yeah. I mean, they
But
do. Jay does need to hurry because time is about to be a problem. 8 seconds left.
You got this.
5, 4. No pressure. Oh. Oh, watch this. Watch this. I'm so smart for this. If we move here, then it's a check, so we have to take it, right? And then we take the
Uh-huh.
rook.
Oh, smart, smart, smart. But then
Yeah.
can't they get the knight?
Oh, yeah, yeah. Oh, I didn't think that one through. Oh, well.
Oh, but time.
Yeah, no time. That's a close game. That's a really good try. That's a really close game.
Definitely.
Yeah. Let's see. Let me look at something real quick. Where's chat relay? How do you play the teacher? I want to play another game. I guess we could play another game. Yeah.
Uh-huh.
Do you also want to?
I don't know how to set up the count.
Oh, okay. I guess I'll
You
set
can
it
do it
up.
on your screen. Yeah.
Okay. Let me see. I'll make this one a bit faster, just for sake of time.
Okay. So speed chess. We've got
Yeah,
this.
speech chat. Go. Okay, let's go. How do I'll send it in chat relay again. Or actually, no, I'll share my screen so you can see it off my screen.
Okay.
Let's see. OBS.